Hello, and welcome to our sixth linear algebra clinic. So today, what we're going to do is we're going to look at how we can use the elementary operations we studied to find the inverse of a matrix. Right. So the idea is fairly simple. What we want to do is take the matrix we wish to find the inverse of, and augment it with the appropriate sized identity matrix. In this case, we want the 3 by 3 identity. Now we RREF it. And if an inverse exists, what will wind up happening is now on the left-hand side, we'll get the 3 by 3 identity, and the right-hand side will give us A inverse. And since we're still in the unit of doing matrix operation, we are going to do this by hand. Right, so our pivot, right, is this 1, 1. So we're going to zero out everything below it. R1 plus R2 would zero out that 2, 1 entry, okay? And then negative 2R1 plus R3 would zero out that 3, 1 entry. Okay. We'll be left with this. Now our pivot is this 2, 2 entry, so we want to zero out the 3 below it. The 3, 2, well, that's simple. Right? Negative 3R2 plus R3. And that will leave us with this. Okay. And now all we have to do to finish up the REF is to take that 3, 3 entry, the final pivot, and make it a 1. The 3, 3 entry is going to be our first leading one that we work with, right? And we want to zero everything above it. So we can just do negative R3 plus R2 and then 4R3 plus R1. And that will leave us with this. Okay. The 2, 2 entry is our next leading one. Right? So we want to zero out the entry above it. And that can be done. Negative 2R2 plus R1. And that will give us this matrix. So look, we got the 3 by 3 identity, right, over here, which means this is our inverse matrix. So there is our inverse. So what we do again is set up the augmented matrix. We want our matrix. And we'll augment that with the 3 by 3 identity. As such. And now let's put this in RREF. Right? So the first step, negative row 1 plus row 2, negative 3 row 1 plus row 3. And that will leave us with this. We need to make that 2, 2 entry 1. So our next step is to do 1/2 row 2, which will leave us with this. Third step, let's go ahead and zero out everything below the 2, 2. So that'll be negative 5 row 2 plus row 3, which will leave this matrix. What we need to do now is make that 3, 3 entry 1. Well, negative 2/3, not row 1, row 3 will take care of that. And that is what we are left with. Okay. So we now need to go ahead and zero out the entries above the 3, 3. Right, and that can be done negative 3/2 row 3 plus row 2, right? And then 4 row 3 plus row 1. And we will be left with this. Okay. Got one more thing to do. Take -3 row 2, add it to row 1. And that will give this augmented matrix. So we see, right, we get on the left-hand side the 3 by 3 identity, which means the matrix on the right-hand side is our B inverse. And we're now set. Okay. This time we have a 4 by 4. Now, the procedure is the same. We want to take the matrix, and augment it now with the 4 by 4 identity. Okay, so what we're going to do is keep this row intact, right? Because we already see that we have a bunch of zeros after it, which is nice. So we're just going to go ahead, take a third of row 1. Okay. Go and zero out everything below the 1, 1 entry. All right, so this is going to require 3 operations. Right, first, negative row 1 plus row 2, then -2 row 1 plus row 3, and then finally negative row 1 plus row 4. And that will give us this. Okay, right? Let's make that 2, 2 entry 1. Right, so negative a half row 2, yeah. That leaves us Zero out everything below the 2, 2 entry, right? That's going to require 2 operations. So we're going to have to do -4 row 2 plus row 3, and then -3 row 2 plus row 4. And that will give us this. You should be able to see a problem. But to be safe, we can go ahead and do another operation. What we want to do is clear out the entries below 3, 3. Right, well, that would just be row 3 plus row 4. And that leaves us right? And that row of zeros in row 4 is an issue, right? Because what it's augmented with, right, what's to the right of the augment is not a row of zeros. So in this case, our matrix C is singular. Another 4x4 matrix. Right? So let's go ahead and try and find this inverse. Right? So take the matrix. And augment it with the 4x4 identity. And now what we want to do is row reduce this. Right? Well, we're going to need to make that 1, a 1, entry a 1, right? Well, that can be done with the operation -1 times row 1. We will now be able to zero out everything below the 1, 1 entry. That's going to require 3 operations, right? -2 row 1 plus row 2, -3 row 1 plus row 3, and then finally negative row 1 plus row 4. And if we perform those 3 operations, this is what we get. Need to make the 2, 2 entry now a 1, right? Well, that's easy, isn't it? That's just the operation -1/2 times row 2. Okay. Let's go ahead and clear out everything below the 2, 2, right? 2 operations are needed for that. We need to do negative row 2 plus row 3, and then row 2 plus row 4. And that will give this. Yeah. Need to make the 3, 3 entry 1. So that's going to require the operation -1/2 times row 3. And I just copied stuff without looking, so that row 3 is wrong. That should be -2, -1/4, -1/2, and 0. Two more operations are going to get us to our result, right? First operation we need to do, -3 row 3 plus row 4. That will give this. Now all we have to do is take a third of row 4, and we should get our inverse. Okay. Well, we get the 4x4 identity on the left, and then what we're left with on the right. And so our inverse is this matrix. And of course, you can always check that the inverses are correct, right? By, in this case, doing D times D inverse and then D inverse times D, and show that you get the 4x4 identity in both cases. Okay. Well, that will do it for this clinic. The next clinic is going to finish up our brief introduction to matrices and linear systems. So in the next clinic, we will be looking at the LU factorization of a matrix. All right, I will see you all then.